Okay, current flow out and current flow in. Okay, so what will be the drawing from the top? This paper. Okay, out dot flow in will be X, X, and X. Okay, so for the magnetic field pattern, dot, you just produce like this one, dot, and all the X. So X will be in clockwise. So this side, clockwise. Dot will be in anti-clockwise. Okay. That is for solenoid. And for solenoid, if you compare the magnetic field pattern with magnet, north, south, magnetic field pattern for magnet is always like this, from north to south, north to south. If you see it clearly, you can see that the magnetic field for solenoid is the same pattern as magnetic field for magnet. Dia punya magnetic field sama. For solenoid, the magnetic field is equal to magnet, usual magnet, north and south pole. Therefore, if you have a solenoid, you can determine which is the north pole and the south pole using the right hand grip. But this time will be different. For the right hand grip, for solenoid, okay, same thing, you must know the current flow, where's the current flow. And the important thing is, where is the current flow on the solenoid. So current flow here, this one current flow up, 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 up. So your other finger showing flow from the front to the back. From the front to the back. So your thumb will point it to the left. Okay. Which direction your thumb shows, that is the north pole. Okay. Mana yang ibu jari tunjuk, arah tersebut itu adalah kutub utara. Okay. Right hand grip, using right hand grip. Okay. So what is the benefit of using an electromagnet? So electromagnet, you can change the power of magnet. You can carry more heavier, you can have a better magnetic field, but there's three ways. Okay, there's three ways so for you to increase the magnetic field. So to increase the strength of magnetic field, there's three ways. The first is by increasing a current. Okay, this you must go back to electric. How to increase the current? First, you can add a battery, you can reduce the resistance. That is how you increase the current. Number two is you're increasing the number of turn. Okay, number of turn. The more turn, lagi banyak kita lilit, will be producing more electric or magnetic field. And the third one is using soft iron core. Okay, so I want to tell you that the number one and number two, okay, the number one and number two, this one also can be asked in paper 3. Paper 3, relationship between current and magnetic field, relationship between number of turn and magnetic field. That's a question in paper 3. One of the popular experiment in this chapter, okay, going out in paper 3 is this one, current and magnetic field. The second one, number of turn and magnetic field. You might go through your past year's question or the experiment to understand more about this. Okay, so basically in electromagnet, first you need to remember is a magnetic field produced from electric when there's current flow. No current, no magnet. So that's number two. there's three ways to arrange it. First, in a straight wire. The second one is coil. The third one is solenoid. Okay. And in solenoid, the magnetic field will be equal as the magnet. And how to increase the magnetic field is by 1, 2, 3. Increase current, increase number of turns, and use soft iron core. Right? Okay, so let's see the question that I sent you yesterday. Okay. That I sent you yesterday. We stop sharing this. I want to share you new things. Welcome to all. Okay. So basically you can referring to this one. Okay, the one that I sent you yesterday in the group. Okay, I've sent you yesterday in the group. Okay, I've written in the group. Okay. Okay, so basically, this is the point. Okay. Okay, we'll be looking to the question number 1. Diagram show two compass L and M used to determine the direction of magnetic field around a straight wire carrying a current. Okay, first they told you that this is a straight wire. Okay, straight wire that is carrying a current. That means that wire will have a magnetic field. Okay. Then, when the switch is closed, what is the direction of compass L and M? Okay. So anybody want to try? You can unmute and tell me the answer, or you can also give the answer in the chat. Okay. In the chat. You can. Okay. Okay. So this one. A. One answer I have here is A. Okay. Let's see. First, you need to know where's the current flow. This one current flow up here to the from the top to the bottom. So they flow in. Okay, in. So your thumb should be down, the other finger showing clockwise. So if the other finger showing clockwise, M should show at the bottom. If you have compass here showing to the left, L will show to the top, this one will show here. So the answer is, yep, A. Okay. Second one. Diagram show a pattern of magnetic field from experiment. Okay. Magnetic field from experiment. So the magnetic field pattern is caused by which one? The bar magnet, the solenoid, straight wire, or circular coil? Okay. Good, most of you answering correct for number 1. Okay, Najwa, Fazna, Adiba, Mrsm, thank you for answering. So for number 2, pattern magnetic field or experiment, which one? Okay, one answer B. Okay. 2, 3, B. Christina also B. Najwa also B. Right. Okay, the answer is donkey. Okay, the answer is donkey. So why donkey? Because you see here, there's one dot and one X. It's like the previous picture is like this one. It is like this one. Okay, it's like this one. So the answer is, this one is for a circular coil. Okay, a circular coil. Okay, good try. Okay, we go to the next question. Right. So this question is a basics. The diagram given is a basic arrangement for the experiment of electromagnetic. Okay, the basic arrangement. Okay, the question is, what change should be done to increase the strength of electromagnet? Okay, so to increase the strength, as I told you, there's 3 ways. Always remember the 3 ways. It's always the 3 ways. Okay, increase the current, increase number of turn, and use a soft iron core. So based on the following, what is your answer? Right. Okay, C. Okay, good. Okay, good. C. Yes, C. So C, because increasing the number of battery, that means you increase the power, the volt, and you will also increase the current. Okay, increase the volt, increase the current. This is VIR. You learn in chapter electric. Okay, voltage or potential difference directly proportional with a current. So if you increase the volt, that means you also increase the current. That's the thing that you need to understand. That's the relation between chapter electric and also this chapter. Okay, good. That's a very fundamental thing about this electromagnet. Then we go to this one. Okay. Can I continue? We have 4 subtopics in this one. The first one we have covered is just electromagnet. The second one is force on current carrying conductor. And the third one you learn about induction, which is most of you doesn't understand about this. Okay, and the fourth one is transformer, the very basics. Transformer, you learn already this one in P33. Okay, the new one will be the induction actually. So, and this one, force current carrying conductor in magnetic field. So the first one, in force carrying conductor in magnetic field. Okay, I want to show you the difference first. What is the difference between this subtopic and the next subtopic, which is induction? Okay, if you're referring to the picture, it shows you almost the same picture, almost the same. The difference is, for force on current carrying conductor, you have a battery. Or sometimes they don't show a picture of a battery, but they have something like this. They put an arrow and they put I. I is for current, meaning there's a battery there. Because current cannot flow if you don't have a battery, a power source. Okay. So if you see a picture of a battery, a wire or conductor, and magnet. Okay, there's three elements: battery, wire, and magnet. Basically, this is a force on current carrying conductor in magnetic field. So if you see these three, that means you need to use a Fleming left hand rule. Okay, you need to use a Fleming left hand rule, which is you want to determine the force. You want to determine the force. Okay. The difference between that picture and this picture, that subtopic and this subtopic is, here you don't have a battery. That battery is changed with galvanometer. Okay, galvanometer. So galvanometer will show you, okay, will show you the magnitude of current, magnitude of I is current, and also will show you the direction of current that we call as induced. We call it as induced current. Okay, induced current I, still a current. I told you I'll be teaching this after this about induced current, so you may understand. But first, I need to make sure that you can differentiate between these two subtopics. If you can differentiate, it will be easy for you. This topic will be very, very easy if you can differentiate. So first, if you saw a battery, a wire, and a magnet, there's a force in current carrying conductor in magnetic field. Okay. So the very basic of this is the one that we learned before. So current here, battery is positive at the back. So current flow to the back, flow here, flow here. So the most important for you to see is where the current flow. Okay, where the current flow between the magnet. Either is flow out, like this one is flowing out. If I change the battery positive to the front, okay, if I change the battery positive to the front, it will flow in. Okay, if I change the battery current flow from the front, it will flow in. Okay, so the battery, the direction of battery, the positive and negative is really, really, really important. Okay, so we've learned already. Flow out, dari belakang ke depan, flowing out. First you saw north and then south, flowing out. Okay, in flowing out, you use dot. Flowing in, you put X. That's the same basics in the first subtopic. Out is dot, X is in. Okay, so now you have dot. Okay, using your Fleming left hand rule, so okay, focus on me. First, you have left, your left hand, and be like this. All three is in 90 degrees. Okay, so F or force is your thumb. Magnetic field, okay, magnetic field always this one, north, and at the end of your finger is south, north to south, north to south. And this one, your middle finger is a current flow. Okay, so for this question, north to south and current flow out, which is current flow to me, the direction is to me, towards me, my thumb is pointing up. That means a force, okay, force is up. So this wire will be pushing up. Okay, will be pushing up. When the current flow or you on, okay, and the current will be showing you direction, upward direction. Okay, let me I share you from this one. Okay. Okay, so be showing you up, right? So it's like this. Basically, how it's happened. So it's happened like this basically. I have a north pole and south pole. Okay, north pole and south pole. My magnetic field for the magnet is always from north to south. Always. Okay, always. So magnetic field for magnet always from north to south. Okay. And current flow out, meaning I put it dot here. So for the dot, if you remember the first subtopic electromagnet, dot current flow out, rotation will be in anti-clockwise. So this side, this side, this side. Okay. Focusing on the top and at the bottom. So at the top, the direction is different. One to the right and one to the left. At the bottom, the direction is in the same direction, both to the right. Meaning, the magnetic field at the bottom is stronger than the top. Therefore, the magnetic force at the bottom push the wire up. Okay, push the wire up. Because the same direction. Okay. So we have around 1 minute and I think I'll be going to continue this subtopic. After this, we take a break first, around 5 minutes, and I give you a new ID in the group, and you can log in back. After the 5 minutes, we continue to discuss on this one and motor. Okay, DC motor. Right? Okay, there's a chat. All right, thank you. See you again in 5.